Question 2 from the yellow book. I call it 2 plus because I altered the question. I have altered the question a little bit. I'll leave the question 2 in the original statement for you to think about. I have altered it a little bit, so look what the question says. It's a question, it says, is the set consisting of 5 numbers like so? In the actual question, I have 10 numbers from 0 to 9, 10 integers from 0 to 9. I shorten it to the set from 0 to 4, not because I want to make it easier, because actually I want to just show you a little bit more than the question expects from us. The question is whether it's closed under addition, and actually I extended the question to under times, undertaking the inverse, and negative, and undertaking the inverse. What will be your judgment to this question? Let's just first part, closed undertaking sums. Do you think this set is closed undertaking sums? How would you convince me that it is not? Say again? You just suggest an example where it fails, right? When we try to disprove something, we suggest an example, and it's a very easy example to come up with. You just pick up 2 elements which in sum will go beyond number 4, and you're done. So 2 plus, I chose 2 and 4. We know, well, they are coming from the set S. That's my notation, belongs to. But if you add them up, it will be number 6, which is not in the set S. And that's why this set is not closed under addition. Similar argument can be presented for the times. If I take numbers 2 and 3 from my set, if I multiply them, it will be 6 again, which is, again, not in my set S. So the first 2 questions, they are the answers. So if I have these 2 operations plus and minus, here's the answer no, here's the answer no, here's the answer no. Again, we can easily come up with the example, and here also the answer no. So in fact, this set is not closed under any of the operations, 2 basic ones and 2 derivatives of those 2 basic ones. Right, the question is easy, and we're done with the question 2. However, look what I can do now. How I can make a minor alteration, and this set S will turn into the set which is closed under all 4 operations. I'm lying a little bit. You'll see where I'm lying. Look at this. Let me just change my operations a little bit. What if I now introduce new plus operation? Not my regular plus, we know from the, from the beginning of times. But slightly new times, this times. I will use a different notation for that times. You see, I put the plus in the circle. I call it all time, or all plus. I said times, I meant plus. So if I alter my plus into the new plus operation, which adds 2 integers, and then take the remainder by modulo 5. So this time, 2 plus 4 will be 6, but when you take the remainder, it will be 1. So 2 plus 2 by new plus 4 will be 1. It is in my set. What if I take, for the times, I make similar alteration. I take my new times in the circle, which again multiplies the integers, and then take the remainder modulo 5. 2 new operations. Well, obviously, with respect to these 2 new operations, because when you take the remainder of modulo 5, the result will be 0, 1, 2, 3, or 4. That's all the possibilities for the remainder. Obviously, this set S will be closed under my new plus and under my new times. The interesting question is whether it will be closed undertaking the negative and undertaking the inverse. Obviously, when I say negative and when I say inverse, I mean negative and inverse with respect to my new operations. And at this stage, we have to bring in our heads what we mean by the negative. The negative is a special number which you add to the original number, and the result is 0. Right? That's the definition of a negative. The inverse is a special number which you multiply by the original, and the result gives you 1. Every time I say add or multiply, this time I mean this to add, and this multiply. So what your judgment will be? Will this set be closed undertaking the negative and undertaking the inverse with respect to my new two operations. Any wild guesses? Yes, no, it's only 50% chance of making a mistake, right? Plus, I don't know any of your names, so there's no risk of running, like, developing a, or making a bad impression on me, right? Yes, no, no, yes. Negative is relatively easy. The inverse is the hardest part. As usual, inverse is always the hardest part. Yes, no? We can do it like this. Basically, it's a finite set, right? It consists of 5 elements altogether. If you try to add 2 elements from this set, there will be only a limited number of possibilities, right? It will be at most 25 possibilities, 5 times 5. You know some probability already. Sorry, not probability, it's not probability, it's combinatorics. If the same story goes with the times operations, again, it's only at most 25 possibilities. Given that it's symmetric operations, even less than that. Right? So we can combine all of the results into tables. Here are the tables. Look at this. You can build these tables using, for instance, Maple or MATLAB. I did this some time ago. Here they are. Tables of my new operations. So it says this. I mean, if you take plus operations, for instance, 2 plus 4, the result is 1, something which we checked already with you. Any other combination, 1 plus 1, the result is 2. I hope you understand how I built this table. I took every possibility from this set, I add them up, and I took the remainder by 5. And I entered the result in the corresponding cell of my table. The same was about this new times. Let's just see if my set is closed under the inverse. For instance, taking the negative. Number 2. What will be the negative of the number 2? It will be the number it will be such number which you add to the number 2, and the result of this addition will be 0. Here. To end up with 0, we have to add 3. So the negative of 2, listen to this carefully. The negative of 2 with respect to my new operation plus is 3. Here it is. Negative 2 equals 3. Who would believe such a heresy, right? We'll just see if any other elements have a negative. For instance, 1. Does it have a negative? Yes. To end up with 0, we need to add 4 to 1. Number 2, we just figure out it's 3. Number 3, obviously, it will be 2. Number 4, to end up with 0, we have to add 1. Every element has a negative. So the answer here is yes. We closed undertaking the negative. What about the inverse? The inverse is an element which you multiply by the original and you end up with 1. Let's just look at the 1. What should we multiply 1 with to end up with 1? 1. Quite expectable. 2. What should we multiply 2 with to end up with 1? Here's 1 in my table. I have to multiply 2 by 3. So in other words, it's another heresy for you. The inverse of my 2, which is, we know, it's like a conventional notation for the inverse is 1/2, is 3. Yeah, it is. It is. Look at this. So multiply 2 with, if I multiply 2 with 3, I will end up with 1. Inverse of 3 is 2. Inverse of 4 is 4 itself. It's not an interesting thing, huh? The inverse of 4 is 4 itself. And so my set is closed under taking the inverse. Any questions?